This conference will now be recorded.
Hello, and welcome to another Oracle Cloud Infrastructure presentation. This one is a demo, so it's a fun one. And what we're doing right now is creating a virtual cloud network. And we are doing that manually. So what does manually means? As we log in into our tenancy, and here you can see that I'm already logged in. If you click here in the top left hamburger icon menu, you will find networking in the drop-down pick list. And under pick list, these are all the topics of networking, and we eventually will cover all of them. Right now, let's go ahead and click on Virtual Cloud Networks, and then you are going to find that you can create a VCN two ways. So this demo is for create VCN, the button. This one is the manual one. And we call this manual because the VCN that you create comes with no additional resources other than the default route table, which is empty, and the default security list. No subnets and no gateways whatsoever. With the wizard, and we will be creating another VCN shortly, it comes with additional resources. So let's go ahead and create our VCN. It's really easy. Make sure that you are in the right compartment and you are in the region that you want. So let's go ahead and start. And the first thing to do is to give it a name. But before I do that, I want to point here to this field. We highly recommend that you don't have overlapping CIDR blocks. Even if you're not going to connect the two VCNs, do not have overlapping CIDR blocks is our recommendation. So I'm not going to be using that one. And I'm going to be calling this manual VCN. That's the name. Now here you enter the CIDR block. So 10.1.0.0/16 with my CIDR block. Make sure that you press enter. Otherwise, it will not take the input that you provide. And I'm going to use the default DNS resolution. And we're not dealing with IPv6 at this moment. And that's all you need. You go ahead and click create VCN, and then your VCN is going to be created. And as easy as that. So as you can see, it comes with 0 subnets. It comes with a default route table, but if you open it, no rules in it whatsoever. It does not come with a dynamic routing gateway attachment. It does not come with local peering gateways, NAT gateways, service gateways, nor the internet gateway. It comes with nothing. You have to create everything from scratch. And we are going to be doing that later on. So this was the demo. I hope that it was of value to you, and I'm looking forward to seeing you in the next demo, which is creating the virtual cloud network through the wizard. Hello, and welcome to part 2 of our VCN creation demo. This time, we're creating a virtual cloud network utilizing the VCN wizard. And as we saw from the previous lesson, in order to find your VCNs, you log into your tenancy, and in the top left, you have what we call the hamburger icon menu. You click on it and you scroll down all the way to networking, and then you will find your virtual cloud networks to the right. And as you can see, here's the VCN that we previously created in the previous demo, the one that already existed. And as you can see, they don't have overlapping IPv4 CIDR blocks, and that's a good thing. That's what Oracle Cloud Infrastructure recommends. And in order for you to create a VCN with the wizard, you click the VCN wizard button, and then it will offer you two options. One of it is creating a VCN with internet connectivity, and the other one is site-to-site VPN. And we'll see this later on. Now, when you create a VCN with the wizard, it comes with additional resources, as we previously explained. And these resources are a public subnet, a private subnet, and 3 gateways: the internet gateway, the NAT gateway, and the services gateway. The internet gateway will provide you with connectivity to the internet and from the internet. The NAT gateway provides connectivity to the internet. And the service gateway provides connectivity to the Oracle Services Network. Let's go ahead and create our VCN. It's also really simple. You give it a name, and this one is going to be called Wizard VCN. We make sure that we are in the right compartment, and then we have 3 fields for CIDR blocks. Remember that we're creating 2 subnets, so you have to specify the CIDR block as well for the subnets and for the VCN. And obviously, the subnets needs to be part of the VCN block. And because this block is already taken, we are going to be changing this to a .2. And that's all we need right now. With the wizard, it does not provide you with IPv6 connectivity options. You can add that later on manually. And then the next button will basically confirm your options. And if there's something that you don't agree with or that you mistakenly type it, you can go back and change that. For example, here we can change the CIDR block or give it a different name, but we don't want that. We are perfectly fine with the options that we selected. And you can scroll down, see the route table rules, see the security list rules, but you can only see them. You cannot edit them. And then you can go ahead and create. And just like that, the process of creating your virtual cloud network begins. And it takes like about 30 seconds to 45 seconds to create. And once you do, once the VCN is created successfully, you click on this button so you can view all the details. And that's what we're doing right now. You can see the CIDR block prefix that you selected. And if you want, you can add more here. Now the route table, we have 2. We have the default one. And as you can see, this one is populated. Let's go ahead and see the route. And you will see that the quad 0, this is the destination to the open internet. And the target is the internet gateway. Now let's go ahead and check the other route table. We created one specifically for the private subnet. And you can see it comes with 2 rules. Remember that we have 2 additional gateways on top of the internet gateway. One will provide access to the NAT gateway. Now, why will this conflict with the other route table? We're using a quad 0. No, it won't, because the other route table is applied to the public subnet, as we will see shortly. And this one is applied to the private subnets. Now, this rule looks a little bit different, and we'll explain what this is when we get to the services gateway. Now let's go ahead and take a look at the security list. The security list looks exactly as the one that we get when we create the VCN manually. And here it comes with 3 default rules. It always comes with this set of rules. This will enable access to any compute instance that you create through port 22. And then we mentioned that these ICMP rules are not for pinging. These are for troubleshooting. Let's go ahead and take a look at the security list that we created, or that it was created when we create our manual VCN. It's exactly the same set of rules. Port 22 and our 2 ICMP set of rules. Now, the other thing that I want to highlight from the wizard VCN are the subnets that we created, or that the VCN wizard created. So we have one that is the public subnet, And if we open it, you will see that the security list is the default security list that's applied to it. Now, if we see the other security lists, or if we see the other subnet, we will see that it's using the security list for private subnets. And it's also the same set of rules, but the difference here is that this is not the quad zero. This is being very specific and allowing access only or from within the VCN, not the subnet. And finally, what I want to highlight here are the additional gateways. It did create a NAT gateway for connectivity to the internet, initiating from within your virtual cloud network and specifically from your private subnet, and another one for your service gateway. And that's basically what I wanted to cover in this demo. I'm looking forward to seeing you in the next one. Thank you very much. Hello, and welcome to the public subnet demo. Not only are we creating a public subnet, but we're also creating an internet gateway because they go hand in hand. In order to enjoy the resources that you have on a public subnet, you need to have a path to them, and that's through the internet gateway. If you recall from the manually created VCN, it does not come with any resources. If we go back into our virtual cloud networks and we click on our manual VCN, you will see that it does not have any subnet, no internet gateway, the route table is empty. So let's go ahead and fix that. We are going to be creating a public subnet, an internet gateway. We're going to be adding that internet gateway to the route table. So let's go ahead and do that. It's really easy. You click on subnets, click the create subnet button, give it a name. Here, I'm going to call this manual subnet. And you can change the compartment if you want to do that. We are going to leave it in the same compartment as the VCN is. Now, if you recall from the actual lesson on the public subnet, we have two types: regional subnet and availability domain specific subnet. This will take advantage of all three availability domains within this region. And this one will use the one that, that we create. Here we get to select what availability domain we want. We're going to go with regional. Now the IPv4 CIDR block, you need to make sure that it belongs to the same CIDR block, or that is a subset of the CIDR block that you selected for your virtual cloud network. In this case, it's not. If you recall, and here it is, you can see it, it's grayed out, but you can still see it, 10.1.0.0/16. The example does not correspond. So if I use this, it's going to give me an error message. So it needs to be within, and it makes sense, correct? Now we are not dealing with IPv6 in this lesson. And now regarding the security list, we only have the default security list. So if we leave this empty, and this is what we're doing, is going to select by default the default security list. So it's as easy as that. You create your subnet. Now, if I was to create a resource in this subnet, like a compute instance or a load balancer, I will not have access to it because I don't have an internet gateway. So while this is being created, it's already completed, but let's go ahead and create an internet gateway. It's also really easy. You just give it a name, and I'm going to call this manual IG for internet gateway, and leave it in the same compartment as the virtual cloud network is. And as easy as that. But we're still not done. We need to add this internet gateway to the route table. So let's go ahead and do that. We don't need to create another one. We're going to be using the default route table. And let's go ahead and add a route rule to it. And now it's going to ask me to select what's my target type. In this case, we do want an internet gateway. And by the way, we don't have any one of these right now. Those are future lessons or future demos. Now I'm going to enter the quad 0 for everywhere, so I can access it from my workstation at my office. And then you get to select your only internet gateway that you have. And optional description goes here. And that's all you need. So now I should be able to SSH into any compute instance that I add into this subnet. So we don't have a compute instance. The ones that we previously created are in another virtual cloud network. And I'm actually going to rename these ones to Wizard VMs. And the new one that I'm creating is going to be Manual VM1. As you can see, I created 2 additional virtual machines. And the reason why I created 2 instead of 1, like I said I would, is I want to highlight one of the features of the subnets. And remember that our type was a regional subnet, and therefore you can see that here the availability domain for Manual VM1 is availability domain 3, and the Manual VM2, which is still in the same subnet, as you can see right here in the 3rd octet, we only have one subnet in that virtual cloud network, is an availability domain 2. So they're in different availability domains. That means that they're in completely different data centers, and they're independent from each other in terms of resources, but they still belong to the same subnet, these 2 virtual machines. And as you can see, I renamed these ones, so it's clear that these ones belong to the manually created virtual cloud network, and you can see that in this octet right here that is different from the Wizard one. So let's go ahead and take a look. Here you can see that it does belong to the manual BCN and that we created all of those resources, the subnet, internet gateway, and our route rule in the route table. So now I should be able to copy this address right here and SSH into it. So let me see, because only one has a key. So make sure that I'm in VM1, and I am. So I'm going to up arrow here, and I'm going to change the IP address to the one that we just copied, paste it, and I should be able to SSH. And yes, this is the first time I'm logging in. So there it is. I'm in Manual VM1 through the internet gateway that we just created. So let's go ahead and remove that internet gateway. First, I'm going to exit out of here. So I'm out, and now I'm going to go into my virtual cloud network and remove the internet gateway. I actually cannot delete the internet gateway because it is part of a rule. So I need to remove it from the rule itself. Otherwise, I'm going to get this error. So I'm going to remove it from this route table. And I can click here on it and remove. And I'll say, yes, I confirm. So now we don't have the internet gateway, so we don't have access into that virtual machine. And this should time out, and it is doing that as well as timing out. So this completes this demo. Hello, and welcome to a new demo of an Oracle Cloud Infrastructure Service. Today, we are creating a private subnet. And not only that, the objective is to create a private subnet, but we additionally are going to be testing a feature of the security list in that subnet. So let's go ahead and log in into our tenancy. And we are going to be going to networking, virtual cloud networks. We already know how to get there. So let's go ahead and do that. In our previous demo, we created a public subnet. Now we are creating a private one, and we are going to be doing this one differently. As you recall, this is a regional subnet. Our private subnet is going to be availability domain specific. So it's really easy to create. You give it a name. So I'm going to call this private. Subnet. And I mentioned that it's going to be availability domain specific. And here I need to specify an availability domain because my virtual machines on my public subnet are in availability domain 2 and availability domain 3. I'm going to force this one to go to availability domain 1. And again, the CIDR block needs to be in the same range as that of the virtual cloud network. So remember that we fix it here by entering 1. Oh, why is it not working now? Because this octet is already taken, the .0, this third one. So we're gonna change this into a .1 and this will fix the problem. There we go. And that's all we need, except that here we need to indicate that it's going to be in the private space. Now, it's as easy as that. We created our public subnet. Now, I did mention that we are going to be modifying the security list. Why is that? That is because if I log in into the compute instance that I have for my manual subnet, in order to prove that the resources in my private subnet are reachable, I should be able to ping to them. Remember that there's no need for a route when you are within when your resources are within the same virtual cloud network. We removed the internet gateway in the last lesson. Add that internet gateway back, and I'm going to create a compute instance in the private subnet. As you can see, I have not created the virtual machines yet. I did add the internet gateway to the route table on the public subnet. However, the reason why I have not created the manual VN yet is because I want to show you something. When you click on create instance here and you give it a name, I'm going to call this private manual VN, long name. Now here it's asking me, where is it that I want to place this virtual machine? Remember that I created my private subnet in availability domain 1. So what happens here if I select availability domain 3? Should not be possible, correct? So let's go ahead and test this. So when you're specifying the network, you need to manually select the virtual network that you want. And here's the manual VCN. And then it's going to ask me, so what subnet do I want? And see, it's not giving me the private subnet because it's not in availability domain 3. Our subnet is here. So if I change this to availability domain 1 and then scroll down and click on the subnet, now it's going to allow me. So this is what I wanted to show you. And now, because I'm selecting this private manual subnet, if I select the public one, this is not grayed out. Here I have the option of selecting a public IP or not. Do not assign. Even though I am in a public subnet, assigning a public IP to the instance is optional. It doesn't become optional. It does not become optional when I do have a private subnet. As you see, the radius change from this circle to this one. And here I'm not going to be adding an SSH key because I'm not going to be accessing it. So I can go ahead and create this instance. And yes, create anyway. I don't need the SSH access to it. So now if I go into my instances, you will notice the difference right away. No public IP because I did not assign one. Now the second octet indicates that I'm in my manual virtual cloud network. And the third octet is different from the one below. It means that I'm in my private subnet. So now if I SSH into this compute instance, the public one, and if I try to ping this address, remember that I mentioned that ICMP is not enabled by default. So let's go ahead and test this. So I'm going to SSH and the address remains the same. No, I'm going to be using this one. I don't have a key to this one. I should actually delete this one. I already proven the point. So let me up arrow, and I should be accessing, and here I am. So now if I ping the IP address of the private IP 10.1.1.87, it's not going to work because ICMP is not enabled. And I'm actually going to leave this running, and I'm going to go and enable ICMP. So let's go ahead and do that. You go into, and you can do it two ways. You can do that on the network security group or on the security list. So this time we're doing it on the security list. So I'm going to go into my virtual cloud networks and click on my manual VCN, go into the security list right here, default security list, and we need to add a rule for echo. And here I can do the quad 0 as we normally do, but now I'm going to do something different because you might recall from our lesson on RFC 1918 and our lessons on CIDRs, the BCN allows only from /16 to /30 for the BCN CIDR itself. However, for the source, it can be anything that you want, including 10.0.0.0/8. So here the /8 is actually permitted. In this way, I will ensure that any virtual cloud network that I possibly peer in the future against this BCN, if it's in this range, is going to be able to connect. And then I select the protocol, ICMP, and I can either select all types or type A, which is echo, as you can see right here. And I can type in the description for echo and add the ingress room. And the minute that I add it, ping should start to work, and there it is. It's working. So this completes this demo. Hello, and welcome to another lesson of Oracle Cloud Infrastructure. Today, we are seeing a demo of a network security group. Not only are we creating one, but we're also using it. And by using it, we are going to be comparing it to a security list. In between demos, I created 2 compute instances. And let me show you these compute instances. I named them VM1 and VM2. And from this address that we're seeing right here, this is the private address. You can figure it out that the second byte from left to right indicates that we are in the wizard BCN that we previously created. Now the third byte or octet indicates that it's in the public subnet. Let's go ahead and take a look if that is the case. Here's our wizard, and as you can see, this indicates that in fact it is the wizard BCN. And if we open it, remember that it comes with 2 subnets, one of them public and the other one private. So the public one is this one right here. The third octet from left to right is 0. And I want to highlight the security list. Here, the default security list is the one that is applicable to the public subnet. And if we open it, you will see that by default, port 22 is enabled in every single security list that is created by default with the BCN, with the wizard, and with the manual creation of a virtual cloud network. Port 22 is always enabled. And we are going to be logging in into these compute instances through SSH because that's enabled. And these are the addresses. And I'm going to be logging in from my workstation at my office. So as you can see, this is the public IP address. Remember that it's in a public subnet, so I do have access through the internet gateway to these instances. And we'll see the route table again shortly. But let's go ahead and SSH into this instances. Right now, we are going to be logging in to VM2. Actually, let's go and log into VM1. This is the address, and the access is successful. If I exit out of here, and then I try logging into the second VM, it should also be successful because they are in the same subnet, and therefore the security list applies to the VNIC of these two compute instances. Now, if I go back into the virtual cloud networks, and first I want to show you the route table. It's giving me access to the internet gateway from quad 0. That means from anywhere. And I am in the open internet. My workstation is at my office, so I'm logging in into Oracle Cloud Infrastructure through this internet gateway. Now, if I go back to the wizard, and let me make sure that I'm out from here, I'm going to exit. And I'm going to clear this. And what I want to do now is go back into the security list and remove port 22. Here, we're going to remove this, and it's gone. No longer I have access, and you can remove it. The fact that the VCN creates this port by default, it doesn't mean that you have to use it. You can always come in and remove it. So because it's gone, I should not be able to log in into any one of these instances. This one should fail. It's going to take like 45 seconds to time out, and access to it is not going to be possible. Let's go ahead and check these compute instances so we can see the address of them. This is VM2, and it's still trying to connect. And there it is. It failed. It timed out. The same thing will happen to the other compute instance. It's going to time out. So what I want to do now is create a network security group that is going to grant me access into one of the virtual machines, but not into the other one. So because I'm trying to access to VM1 right now, this is the one that we are going to create a network security group. And here you can find out that I'm in this public subnet and that I am in this virtual cloud network. So if you open the virtual cloud network, you will see that the network security group link contains 0 network security groups. One of the differences between a security list and a network security group is that network security groups are not created by default when you create a virtual cloud network. So you have to come in and manually create it. So we are going to do that. And it's really easy. Click on the create network security group, give it a name, and I'm going to call this network security group, actually wizard. Wizard because I want to highlight that it belongs to that virtual cloud network. And then you enter the rules. And this is going to be stateful. That means that I don't have to create both an ingress and an egress, only the ingress one. In this case, my source is going to be a CIDR, and it's going to be from anywhere. That's what quad 0 means, from anywhere. And I want to be very specific to the SSH protocol, port 22, from anywhere. And then this is optional, network security group 1, whatever description you want to add to it. And that's all you need. You create the network security group, but it doesn't stop there. You need to go here and add this network security group to the VNIC of the compute instance. So this is what we are going to be doing right now. You go into the instances, and I'm going to add this to my virtual machine 1. So the VNIC, in order to find the VNIC, you scroll all the way down, and here you'll see the attached VNICs. And we have one, the one that was created by default when you create the compute instance. You click on it, and then you edit the network security groups field here, says none, and then you select one. And we only have one, the one that we just created, the wizard network security group, and then you save the change. Now this will grant me access into my virtual machine 1. If I up arrow, here it is, and there it is, through the network security group. However, because we only added it to virtual machine 1, virtual machine 2 should fail. This is .13, and this one will still time out. So that's the key difference, and that's how easy it is to deal with network security groups. I encourage you to further investigate on it and play around and try to reproduce this demo if you can. Thank you very much. Looking forward to seeing you in the next lesson. Hello, and welcome to the Bastion service demo. In anticipation to this demonstration, I went ahead and deleted some of our instances, actually all of them but one, and I renamed this virtual machine to Wizard Public VM1 because we're creating one that is going to be private. Remember that we utilize the Bastion service to gain access into private resources, and I'm going to go ahead and create this instance because I want to highlight something very important that is needed for you to be able to access the resource as a managed service from the Bastion service. So let's go ahead and name this compute instance. I'm going to call it Wizard Private VM1. And I'm going to leave it in availability domain 1. Actually, just for a change, I'll change it to availability domain 2. Here, we need to specify that it's going to be in the public subnet and the private subnet, I should say. And we need to, as an extra security measure, grant them keys. So these are the keys that I use for my demos. And this is what I want to highlight. Here under Show Advanced Options, you click on it and you go to Oracle Cloud Agent. And these are the agents that are provisioned by default into your compute instances when you create. However, the Bastion is not checked. So you need to go ahead and check this in order to securely provide access through the Bastion service. And in order for this to work, you need to have either a NAT gateway or a service gateway in your private subnet. And the reason why is because it reaches the Oracle Services Network through either the open internet or through the service gateway and retrieve this agent. So this is why I wanted to create this compute instance in front of you. And while this is being created, now we can go ahead and move on into our topic, which is Bastion. So click on the hamburger icon and scroll down to networking for everything regarding networking. And Bastion service is a security feature for our networking resources. However, it is not located here under networking. We also have an item for identity and security. So to work with the Bastion, you have to scroll down all the way to identity and security and click here on Bastion. And as you can see, I don't have a single Bastion service in my networking compartment. So let's go ahead and create one. And this is going to take a little while, but I can pause the recording and come back when it does provision. So the name of it will be Bastion Demo. Now I'm going to select the virtual cloud network. In this case, it's my Wizard VCN, and I'm going to be using the private subnet because that's where my services are, and I want to place the Bastion service endpoint in my private subnet. Now, the CIDR block allow list, this is from where, through the Bastion, I can access my private resources, and I can be very open-ended and enter 0.0.0.0/0, or I can be very specific for additional security and select something that is not that open. In this case, I'm going to select my private IP. That's my IP address. And of course, this needs to be in CIDR format. So I'm going to type /32, indicating that this is the only IP in that subnet. And there we go. I can go ahead and create the Bastion. This means, this allow list means that I am the only one in the whole world that can access the resources in my private subnet. So my Bastion is being created. That's the first step. And like I mentioned, this might take 3 or 4 minutes. So I'm going to pause the recording and come back when it does provision. So as you can see, our Bastion demo is active now. So if you open it, there's another step that we need to take, and that is to create a session. So let's go ahead and do that. We need to create a session, and this session is going to be open for only 3 hours. So that's an extra set of security, only 3 hours. If you compare this to creating a computer instance and using that as a jump box into your private resources, that's open all the time. So it has the possibility of being compromised. So the reason why we highlighted that cloud agent is because you need the agent for the managed SSH session. Now, if you don't have an agent, there's still a possibility, which is SSH port forwarding. Today, we're demoing the managed SSH session. So that's the one that we're going to be selecting. And I'm going to call this demo session. Now, the user is for the compute instance. It can be root. In this case, we're using an OCI compute instance, and the typical users. Now we need to select an instance. Which instance do we want? Of course, we already have access to the public instance through the internet gateway. So this is the one that we need. Now, the SSH key is for the session itself, and I can use a different one from the one that I selected for my compute instance. But in this case, I'll use the same one for simplicity. But you can use a different one, and I'll show you how to use them once we get there. And that's basically it. You go ahead and create the session. And again, this will take 3 or 4 minutes. So I'm going to pause the recording again and come back when it finished creating. You can see this already completed the creation of the session. And now the next step is to copy a command and use that command from the workstation that you're accessing your resources from. In this case, is my workstation in my office. So you can copy the command and then later on use it, but let's go ahead and view the command because I want to show you the key aspect that I was mentioning. Here, this private key, and this is the one for the actual session. And then this is the second key, and this is the one for the compute instance, and they can be different. I chose to utilize the same. And notice how it even includes the IP address of the compute instance and the user that we typed in. So I don't need to copy this because I already pasted it here. Here it is. This is the command. I obviously filled in the blanks where it says private key. I'm using my key or my keys, and the rest, it's the same command. So let's go ahead and access our system. And there we are. So now that we are in a private VM, what is it that we do? Remember that that virtual cloud network, along with the private subnet in it, they were created with the wizard, and the wizard comes with a NAT gateway and a route to the NAT gateway. So let's go ahead and ping this DNS service. And there it is. We can ping. So what happens if we remove the NAT from the route. Should I be able to ping? So it's the wizard VCN, and it's in the route table, and it's our private subnet. So let's go ahead and remove the NAT. So it's gone. So can I still ping? No, I cannot, but I still have access. So the NAT is for the resources to gain access to the outside, and the Bastion host, you use it to gain access from the outside into your resources. Now, let me interrupt this. Now, what happens if I remove the internet gateway from the other VCN or from the other route table? So let's go ahead and remove the internet gateway. And it's gone. No more internet gateway. I'm still connected. I'm going to exit out of it, run the command again. And I can still connect. The internet gateway was not used whatsoever. It was not used at all. And the Bastion is a service that is managed by OCI. So you're using OCI resources to gain access to your private resources. So this completes the demo. Looking forward to seeing you in the next one. Welcome to this Oracle Cloud Infrastructure demo. Today, we are demoing the NAT gateway. And you've seen a demo indirectly of the NAT gateway before. When we demo it, the Bastion service, basically we require the services of the NAT gateway to prove the concept, and we deleted the NAT gateway from the route table of the private subnet. So let's go ahead and take a look at that route table. So we are using the Wizard Virtual Cloud Network. That's the one that comes with the NAT gateway. And as you can see, we already have a NAT gateway here. And if we go to a route table, you will see that there is no NAT gateway. We only have the service gateway in there. I'm actually going to go ahead and remove this one as well. It's gone. So the table is empty, and we are going to log in into the NAT gateway. That's our command, if you recall from a previous lesson. And we are in. So if I ping this DNS address, it's not working. And it's not working for anything. I can also ping this other DNS address. And there's no connectivity. So the minute that we add the NAT gateway to the route table, we should be able to ping. And we can be very specific. Here I can add 1.1.1.1/32. And I have an extra dot right here. So this is why it's not working. So I'm only pinging that gateway. And now we have a NAT gateway. So this is not going to work because obviously I'm only addressing the other service, the other DNS service. So this one should work. And there we go. So this is what the NAT gateway does. Allows connectivity for resources that are in the private subnet to gain connectivity into the open, into the resources in the open internet. So that pretty much covers this demo, and I'm looking forward to seeing you in the next one. Thank you very much. Hello, and welcome to the demo of the service gateway. Now, in anticipation of this demo, I created an object storage bucket. So let me show to you this object storage bucket, and you will be seeing this service later on in greater detail. But for now, This is my bucket right here. I call it my demo bucket. As you can see, I'm in my networking compartment still on my US West Phoenix region. And if I open the bucket, well, first of all, you'll see that it's a public bucket. And if it was private, then access to it will be limited. But for the demo purpose, public is perfectly fine. And as you can see, I don't have any object in the bucket. Now I want to go into networking because we are still leveraging the private subnet of the Wizard VCN. And if I go to the route tables, the compute instance that I'm going to be utilizing resides in this private subnet. And this is it. And as you can see, I have access to the NAT gateway. I still don't have access into the service gateway yet. I want to prove a point. That's why I don't have that access. Now, the compute instance that we're using is the one that we reach through the Bastion service. And this is the instance. It's the one labeled private VM1. If we click on it, well, let me go back. So you can see it doesn't have a public IP address. And if you click on it, you will see that it belongs to the Wizard VCN, to the private subnet, and the IP address is this one. So I can log in to that instance through the Bastion service that we previously demonstrated. So let's go ahead and log in. And what we're doing right now is we are going to be sending this file that we created called helloworld.txt. So let's go ahead and take a look of what are the contents of that file. It says there are 10 types of people, those that understand binary and those who do not. So that's the message that's the contents of the file. And how is it that we're going to be sending it to that bucket? So through the command line interface, because we're in a private subnet right now, and I'm in a Linux system, so I'm going to be using the command line interface, and this is the command. So I'm using my Oracle Cloud Infrastructure command line interface for object storage, and then I'm going to be placing in this bucket, my demo bucket, the file called helloworld.txt, which is this one. So let's go ahead and run this command. And that means that it's been successfully sent. So if we go back into our bucket, and I should open another window, so I can go ahead and open in a new tab. And here it is. So here's my bucket. And now it has a file. Here's the file. So if I go ahead and download this file by seeing the object details and clicking on this link, then here's the file. I can go ahead and open it. And there's the contents. So it got there through the NAT gateway. The NAT gateway, so it didn't use it went out via the internet gateway. I can still ping 1.1.1.1, and it works. Remember that we had a route that was going to 1.1.1.1/32. I changed that to the quad 0, in case you were wondering. And now we are going to go and remove the route from this VCN, the route to the NAT gateway. So, but before I do that, let me go ahead and remove this file from here. More actions, delete it. So it's no longer there, it's empty. Now, if I remove the NAT gateway, I should not be able to send this file. So let's go ahead and do that. So the route table, now I'm gonna leave my route table completely empty, and it's gone. So now if I want to send the file again, there is no route to it. As you can imagine, it's going to time out. So while it's doing that, I'm going to go ahead and add a route table, select my target type, and this time is the service gateway. Select the service. Do I want all services in Oracle Service Network or only those of object storage? You can select either one and both will work because object storage is part of all services in Oracle Services Network. So, but if you only want it to be very specific, you can use object storage. So let's go ahead and do that. Select object storage and now select the service gateway, the only one that we have, and add the route rule. So this by now should have already timed out. I think it did add it once I created this path. So let's go ahead and check because this is the message that it was successful. Let's go ahead and look. And it did the minute that I added that. So it saved me a step. I was actually going to wait for it to time out. But to prove that we are no longer using the internet, now I'm going to ping 1.1.1, and it's not going to work because I'm bypassing the internet. So that pretty much covers this demo. Thank you very much. I'm looking forward to seeing you in the next lesson. Hello, welcome to this new demo of Oracle Cloud Infrastructure. I'm very glad that you're here because it is a local peering gateway, and we are going to be utilizing the resources that we previously created on the other demos. Our two virtual cloud networks, we are going to be peering them together. The one that we created manually and the one that we created via the wizard. So let's log into our tenancy. And again, to go into networking, you click on the hamburger icon and then click on virtual cloud networks right here. And you make sure that you're in the right compartment and you can see your virtual cloud networks. So these are the two that we previously created. So let's start with the .1 at the second octet, the manual VCN. And what we're doing is basically adding a local peering gateway. We have none right here. It's really easy. Just click on it, create the local peering gateway, give it a name, and I'm going to be calling it manual local peering gateway. Then you click on the create local peering gateway. You make sure obviously that you're in the right compartment. And as easy as that, this is your manual local peering gateway. It's available. The status is not peered. Then we have a route table here that you can optionally assign when you're dealing with transitive routing. And then in case there's an advertisement, it will be showing here. And then this indicates if you're connecting to another tenancy. In our case, and for the architect associate purpose, we will not be doing cross-tenancy connections. So we have our first step. Now let's go into our next network. And this is the manual one. We are going to address this one. And remember that the wizard creates 3 additional gateways, but the local peering gateway is not one of them. We do have a NAT gateway, a service gateway, the internet gateway, but no local peering gateway. So we also need to create one here. So this will be the wizard LPG, and then you click create. Same concepts, not peered. So the next step, we already have our 2 LPGs. So the next step is to peer them. So establish peering connection is the first option right here on the 3 little dots that you have to the right. You click on it, and then you have 2 options. Either you browse below for it, or you enter the local peering gateway OCID. And OCID, by the way, stands for Oracle Cloud Identifier. Every single resource has an OCID. So we are in the right compartment. Now let's select the virtual cloud network that we're going to be peering to. In this case, it's the manual VCN. It's also the local peering gateway exists in the same compartment. Now we need to find it, and it's this one. And then you establish the peering connection, and then the status will change to peered, and this will take less than a minute. But while it's doing that, you might recall from the lesson that another step is to establish a route in the route table. And we can go ahead and do that and come and check on the status later on. Well, no need, here it is. So we go to the route table. And in this case, we are going to be leveraging the default route table. And then you add a route rule to it and find the appropriate gateway. The local peering gateway is the appropriate gateway in this case. And then the destination CIDR block, I'm going to be very specific on the traffic. So it's going to be 10.1.0.0/16. So this way it will allow me to reach both the private subnet and the public subnet at the other end. So far, we only have, I believe, a public subnet. No, we did create both of them. We did create a private subnet as well. And this is our local peering gateway locally here. And then the description is optional. Then you add the route. So that's the step that you require here. We need to do the exact same thing at the other end. So we go to our manual VCN, find the route table. Here we only have one. We don't need to create another one. We are going to be adding the rule. Now the destination over there is 10.2.0.0/16. Our next hop is the manual local peering gateway. And again, the description is optional. And that's basically it. That's all we need to do that. So now we can go ahead and log in to a compute instance on our manual VCN. And let's go ahead and check the address for it so I can copy it. So I'm going to be logging in to manual VM1. This is the IP address. I can select it from here. Copy, open my, and the address and there we are. There we are. So now let's go ahead and ping our compute instances, private IPs at the other end. So let's ping and there we go. Now, I hope that you can figure out why this is not working. The reason why is because if you recall from a previous lesson, we enabled type 8 on ICMP echo, but only on one end. And that was the wizard. No, that was the private IP on the manual BN. And this is where we are. We only enable it here, but it needs to be enabled at the other end as well. So let's go ahead and do that. And you can get to networking either through the hamburger icon here, or if you click on the virtual machine, you click on the network right here, and then you find your security list. And here, remember, we removed the SSH. So all we need to do is add this rule right here, ICMP. The last time we used type A for echo. Now I want to be very specific. So yes, I'll use type 8 as well. And this should get it working. And there it is. You saw it live. So this completes the demo, and I'm looking forward to seeing you in the next one. Thank you very much.